The Franklin PF 196 by 72 Plasma Punch Plate Fabricator. Processing heavy plate up to 1/2 inch thick, the 196-ton RAM provides massive power to get the job done. Designed with a 72-inch plate capacity and many unique design features, this heavy plate processor is in a class of its own. The key to a productive plate processor is material handling, which increases arc time. The Franklin Series 4020 or 2020 gantry with vacuum sheet loader provides quick productive loading. The 4020 gantry, as shown, has a 16,000-pound split lift system that works independently or as one full 40-foot system. For flat bar and stripped plate, an optional magnet lift can be provided for parts 12 inches or narrower. The lateral movement and lifting of the basic gantry is manual. Once the plate is positioned and the triple gag press contains 3 heavy-duty heat-treated punch stems. Each station is selected through the CNC Nest software. The number 2 center station has a 2-inch diameter punch capacity. The Hypertherm HT400 plasma cutting system is a high-speed 400-amp power supply designed specifically for heavy plate applications. The plasma cutting system is accurately integrated into the Franklin plate processor, complete with torch height control, gas console, servo-driven torch lifter, water-cooled torch, and all necessary CNC interface for plasma arc control. The plasma cutting system is located on the exit end of the fabricator. The plasma axis is independent of the punch axis. This allows the lower dies to be parked totally clear of the plate being processed. This design feature prevents the lower dies from dragging and possibly hanging up on the skeleton or parts being cut. The outfeed dump table has a 3-position hydraulic sequence that removes the smaller parts from the skeleton and discharges them to a customer-supplied bin. For larger jobs, the optional outfeed conveyor supports the parts and skeleton until the process is complete. Software options in the Nest setup disable the dump table for parts that exceed the zone. The Franklin CNC torch height system supports torch height control, known as THC. The THC controls the arc standoff and monitors the voltage during the cut. This design is essential to the life of consumables and cut quality. On heavier plate applications, piercing from the edge of a punched hole can greatly extend torch life and consumables. The cutting of thin plate on a large machine like the Franklin PF 196x72 plasma punch fabricator requires accurate control of the torch lifter device. The thin 3/16 plate, as shown here, will vary in height during the cutting process. The advanced torch height control monitors the exact arc position even at high speeds of 180 inches per minute. The advanced CNC nesting software sequences each function across the plate in cut zones. All punched holes, part number stenciling, scribe layout, and any interior shaped cuts within the part are performed prior to the final outside perimeter being cut. The high-speed stenciler is attached to the cross-axis of the punch ram. The CNC software automatically reads the DXF text layer and generates the appropriate text for each part. Part marking is achieved by a high-speed self-contained stenciler. The stencil unit is moved to the program start point. The stencil unit has its own XY movement, allowing the heavy plate to be stationary. This design prevents forward and reverse movement, which can introduce error and cause premature wear to the drive systems of the machine. Simple text strings are generated from the CNC Controls part file and downloaded to the stenciler. This provides an easy, simple task of marking parts, even multiple lines, without complex machine codes. Finished marks are deep and can be varied in size at the machine's CNC controller. The stylus used for marking is considered low-stress marking, suitable for facture-critical classification. A heavy pneumatic scriber is an optional device that is mounted directly to the plasma torch axis. Scribed lines can be produced anywhere on the part through the CNC software's DXF layer. The depth of the lines can be varied from light to deep by adjusting the impact pressure and travel speed.